Hey, what's up, y'all? Welcome back to Nexion Analytics, where we turn complex data into actionable, clear insights. So in the last episode, we talked about data warehouses, data lakes, and databases, and how they connect within the ecosystem. But now let's get to a microscopic level, the DNA of every single data set, which is tables, rows, columns, and keys. So whether you're writing SQL or doing things in Power BI or Python, these terms are going to be essential on how you visualize solutions and work with data. Check this out. So first up, we have tables overview. So at its core, a table is a structured collection of data organized into rows and columns, like a digital spreadsheet, but far more powerful. Each table represents a single entity or concept. So for example, employees, orders, customers, or even products. In a relational database, tables are the building blocks. They define what type of data you're storing and how it connects to other data. Tables live inside databases, and databases can have dozens, hundreds, or even thousands of them, all working together to represent a real-world system. So we learned about tables, but what is a column? And what does it exactly do and mean? So think of it as a category of information stored in a table. It defines what each piece of data means and how it's formatted. So each column holds a single type of data. For example, employee name is going to be text, salary is going to be a number, and hire date is going to be a date or time, or even both. These are called data types, and they tell the system how to store, validate, and compare values efficiently. A good rule of thumb is that columns define the structure of your table, while rows define the content. So now the rows, which is where the data actually lives, and each one is a unique record within your table. So each row represents one instance of the entity your table describes. In a customer's table, one row equals one customer. In an orders table, one row equals one order. The intersection of a column and a row is a field. A single value, like your name in the name column, or your date in the hire date column. When you query a table, you're telling the database which rows and columns you want to retrieve or even analyze. Okay, so now let's talk about what makes relational databases truly powerful, which are keys. So keys define relationships, ensure data accuracy, and allow tables to talk to one another. So a primary key is uniquely identified in each row within a table. It ensures that no two records are exactly the same and helps maintain consistency. For example, an employee ID in the employees table or an order ID in the orders table. Without primary keys, tracking or linking data accurately becomes nearly impossible. Next up we have is foreign keys. So a foreign key creates a relationship between two tables. So we know primary key lives within the table, and foreign key now connects a table to another table. For example, in an employees table, a column named department ID might link to the department's table. This allows you to connect information across tables, such as showing which employees belong to which departments, all without duplicating data. Together, primary and foreign keys create referential integrity, which means your relationships stay consistent even as data changes. So just to put it in context a little bit more, this is where your fact tables and dimension tables really come into play and understanding them in full. So some tables use more than one column to form a unique identifier. That's called a composite key. So for example, for course enrollment, you might use course ID and student ID. And that's a primary key still, but that's called a composite key because it's linking more than one together. Others might use natural keys. So natural keys are going to be socials, employee IDs, or something else identifying you as an individual. But in practice, most designs are using surrogate keys, which are going to be generated IDs that are very specific and parent to that row or data. So when you combine tables, columns, rows, and keys, you build a foundation of relational data modeling. It's what allows SQL queries, Power BI relationships, and even APIs to pull and join data from different places, all while keeping everything aligned. So just to recap, tables store entities, columns store attributes, rows hold records, and keys connect them all together. The structure is the language your data speaks, more than anything else. And once you understand it, and now even understanding it even more, this is how you can become more powerful within your workspace or even just building things independently. So if you found this video helpful at all, hit that like button, hit that subscribe button as well. Leave a comment and let me know your thoughts down below. With that said, thanks for watching.